255. So everybody aware of how to converting a binary to decimal, decimal to binary, right?
Yeah.
Islam, what about you?
Yes.
Okay, you are good with the binary to decimal, decimal to conversion.
Yes.
Okay. Okay. Now, so in each field, it will be like 0 to 255 and dot 0 to 255, 0 to 255, 0 to 255. Any value is possible. So here, this is a permutation combination of these things. So we will get more than a 2 billion IPs if you use this one. If you use these permutations and combinations, we will get 2 billion IPs. Now, so IP addresses are categorized in different classes, like class A, class B, class C, and class D and class E also. Okay, so we are least bothered about class D and class C. So our general intention is to understand more about three classes: class A, class B, class C. So in the class A, the IP address are the range of IP address are. Do you know any range of class
Yeah,
A?
from 0 to 126.
Okay, 0.0.02. So if I say, is it correct or wrong? 127 to 255?
Yeah, 127 actually the loopback address.
Correct. So
So
here it is 127, but 127 reserved, again it is reserved for loopback. Okay. Now the next value of this one is 128.0.02. What is the next value?
191.255.
19. Okay. Then next value will be 192, right? After this, it will end up with the 223. 255, the last value 255.255. So here class D is reserved for multicast addressing. So we don't assign this one. We will use for multicasting purpose. Okay. So for certain services, these multicasts are automatically enabled, and this IPs will be like enabled on that particular device automatically. Okay.
Okay.
So we will see more about three classes, and if you want to have a list, I can show you in the. See, for class A, class B, class C, just different. Yeah. So here it is 224 to 239. The first IP address is 224.0.0.0 to 239.255. Two 255. So class E is 242, 255. So these are like used for some reserved purpose, but we don't know what is the reserved purpose still. Okay, so why we know why these IP addresses are come under class A, this range. Why these addresses are come under class B? Okay, why these addresses are come under class C? Do you have any idea?
Class A we can use for bigger network. Class B actually used for the medium, or class C is for a small network environment. Suppose first octet of class C is first 3 octet actually represent the network portion, and the last octet is represent the host portion. So
okay.
For class
so
A,
I mean, I'm saying we are using for that purpose, right? But on what basis they are divided into classes? My question is, on what basis these are segregated under class A? So for class A we are using 8 bits for network and remaining 24 bits for host. But why these subnets only come under class A? Yeah. Majid, hi. Hello.
Hi guys, how are you?
I'm good. We just now started the class. So I'm explaining about the classes. Do you have any idea about IP address and classes? Yeah, Majid.
Yeah, I know some, but I need to refresh. I know about class A, class B, class C.
Okay, good. That's good. Okay. Yeah.
What I missed, I will watch the video again.
Okay. Okay, that's right. Majid. And this is, if you convert any of this value, first octet of class A, if you convert into binary, that will always start with 0. So take the example of 127. 0, 1, 1, 1, all ones, right? So 1 plus 2 is equal to 3, 3 plus 4 is equal to 7, 7 plus 8 is equal to 15, 15 plus 16 is equal to 31, 31 plus 32 is equal to 63, 63 plus 64 is equal to 127. So if you take any value between 0 and 127, always the first octet value, or the first bit of the first octet will be always 0. Okay? So on this basis, the class A is divided. Yes, Ayat. You got this right?
yeah, I know this, yeah.
Yeah,
I
you forgot that
I
one.
didn't get your question, yeah.
Okay. So, Islam, you know, right, this logic? Okay. 128 to 191, if you take any, like the first octet, always the first octet, first 2 octets will be 10. If you convert any of this 128 to 191, always the first octet will be 10. The first 2 octets, so first 2 bits will be 10 in the first octet. And if you convert class C, then that will be 110. Do you want
So
to show me?
always like the class A start with 0 and class B start with 10. Class C start with 110.
So it's not 10, it's a binary 10.
10, I'm sorry.
Yeah. So,
110, yeah.
yeah. So here, if you take binary equivalent of 128, first one is 1, the remaining 7 bits will be zeros. So in this case, the condition is satisfying. 191, first value is, the 191 binary equivalent is like 10, all ones. 1. So this will be remains constant between 128 to 191. So if you take any 130, 150, anything that will be like condition satisfy this condition. Okay. So on this basis, the classes are divided. Now, with the help of classes, now they want to define some network range with the help of mask. So for class A, we have 8-bit mask. For class B, we have 16-bit mask. For class C, it's 24-bit mask. So that means that for any IP address, we have 32 bits, right? So now it is telling that 8 bits are network bits and remaining 8 minus 32 are 24 bits are host bits. Okay. And here 16 bits are network bits and 16 bits are host bits. Here 24 bits are network bits and remaining 8 bits are host bits. So depending on the range of the network, we have to go with the one IP address schema, any one of this. So depending on the host, depending on the networks we required, so we will go with one class and one IP address in that one. So here, is that clear till here? Anybody? Any questions? Yeah, please, yes, no. I mean to say that.
We are good.
Okay, because if anybody has doubt, no, see, if everybody understands, that is okay, but if anybody misses any point, then they can raise question. So here, this is something about the host bits. Now, what is a private addressing? Anybody?
Is it private or what?
Private.
Private, okay.
Private. So anybody knows about private, anything about private network, private addressing?
Yeah, there are some ranges with these three classes. Suppose for class A, 10.0.0 to 10.255 to 55, and for class B,
yeah. So
128.16 to 128.31, and class C 198.168 to 198.168 to 55 to 55.
Okay, so why these ranges? What is that ranges? Why? So what is private addressing? I'm asking, what is a private addressing? Why we use this private?
I don't know.
Okay, Islam. So I don't know who is talking. So Islam, Syed, any like why we use this private?
Yeah, I said I don't know about. Explain, please.
A private
Okay.
address actually is for a local network, and when it goes to public address, suppose we can represent all the network with a single IP public addresses. Or might be that.
Okay, you are telling about NAT, right?
Network address translation.
Okay. So Islam, you are not raising your voice today.
Also, private address are actually reserved for LAN, right?
Yeah.
So they can be
So
used for like a home and office network.
yeah, correct. So here the private address are like just like Islam said. So this is like they are used for private purpose, and these are defined under RFC. So RFC 1918. So RFC 1918 tells about the private addressing schema. Okay. So we can use this network for private purpose. We cannot, like, these networks are globally not recognized. When the internet sees, say for example, I will define the private addressing. It is 10.0.0.0/82 10.255.255.255./8 again, and it is 172, not 128. Okay, 16.0.02 172 31.0.0 slash 12 bit mask. Okay, now this IP address is 192, not 198 dot 168.02 192.168.255.255.
This one I said 192, but that one I said 128.
No, I heard that. So it may be like you are thinking, but you just like me. Sometimes I'm thinking something and I say something. 16. Okay. Okay. Here these networks, basically these networks are not globally recognized. They are not recognized in the internet. Okay. Now when we send a packet with this IP address to the internet, now it will go to the destination, but it will never come back, because these networks are not globally recognized. What do you mean by not globally recognized? If any packet with source IP address, this network, or destination IP address with these networks in the internet, automatically these will consider as an unreachable network by the BGP routers or globally routing routers. Okay, any networking device they will consider as a unreachable networks. Is that clear? Like, so basically from one autonomous to other autonomous system, it will not forward. Okay. Now these networks are used for basically purely used for LAN, local area networks, private addressing, and branch offices. So if you have a private network, so one branch office and another branch offices, and like all the branch offices are connected privately. They have their own dedicated lines and everything, and these offices are like having connectivity to each other. Then they can use a private addressing schema for LAN. So never use a public IP address. And one thing is that this is because why we use a private address? Why we require a private address? Hello? Hello?
Yeah, hello.
Yeah, Syed, why we require a private address?
It's free, and we can use it in our local environment.
Ah, correct. But why we required a private address? In the local, we can use private or public address also.
For more security or
Hmm. Okay. Then okay. Any question? Any answers again? Yeah, Islam. Okay. Then it is regarding the security one thing. And first exam, another thing is that in order to protect the IPs from duplication, I mean to say that if everything is a public network, okay, every IP is a public network, publicly recognized. Then if we assign a public IP address in our LAN, then that PCs or that servers can be accessible from the internet. So that is a big concern. See, if you don't have a private address schema in your LAN, your mobile cannot get the private address. Okay, your printer will not get the private address. Your PC will not get the private address. If there is no RFC19. Everything is public IP address. So if you have a public IP address, okay, then your PCs are reachable from the public. So if you are exposed in the public, then that is a security concern. One thing. Another thing is that, see, if you use every device with the one public IP address, see, public IP address will be that almost it will be like a unique. So we cannot duplicate the IP address from one public IP address in one location and same public IP address in another location. It will not work. Okay. So if you assign everything with the public IP address, see, nowadays we are getting mobiles, we are getting all the gadgets which are running with IP address. So if you assign this all the IPs, then we are end up with all these three classes. So we don't have enough IPs to serve. So to avoid this thing, okay, whatever the required PCs to communicate, like say for example, whatever the PCs they want to come outside and they want to speak in a public, then they should have a public IP address. For remaining, we can use a private address, where the privately first they will communicate privately with the private IP address. Like say for example, this is one branch office, this is another branch office. The PCs are connected. Usually in office, most of the communication depends on one PC to other PC in the LAN, or one PC to server, centralized distribution system servers in the LAN. The most of the traffic is intended here, or the traffic will go from one branch office to other office. So here we required only private address. But for going internet, they will go with, as you said, one public IP address with an AirTag services. Then for the internet, these PCs are visible as these IPs, like PCs, whoever requesting the global or internet, then they will convert this IP address will become as a proxy. This public IP will become as a proxy for all the PCs in the LAN, and then it will go to the internet and it will come back here, and once it receives here, it will remember which PC request what, then it will forward back to the PC. Just here it will act as a proxy. So this is called a NAT service. So for private, we are using a private network address. If you want to go internet, we are again using a public IP address. And see here, if you have 100 PC here, 100 PCs here, 100 PCs here, so then we have saved 300 IPs from public IP address, right? Now we are going with one or two public IP address. So here, if you use every private network with a private IP address, then we have saved a lot of IPs. And one thing is that here, this is a company A. They use here 192 schema, 192.168, 1.0, 2.0, 3.0, and other company B also can use the same subnets, because these companies and these companies are not communicating. Company A and company B is not communicating internally. If really they are communicating, basically they are coming from the internet. Correct? So what is your computer IP address? Tell me now. By checking this IP config all. So I'm using 192.168.1.0. Is that correct? Hello?
Yes, yes.
What is your private? What is your IP address? All everybody should tell.
Hello.
Yeah.
Yeah, mine one is 1.24.
1.24. Okay. Other guy? Huh?
I know mine saying 67.163.49.73.
60?
7.
167 or 67?
Only 67.
So you are getting a public IP address, man. Then I can I will try to access your PC. So usually it depends on the service code. So I'm using a router. Router
No,
will
no, not
service
this one. This is public.
Oh.
Hello.
Hello.
Are you using laptop or tablet?
I'm using laptop.
Oh, I have a tablet. Can I find out how?
No problem. It's
How I
not
can do
necessary. I don't know which which tablet you are using.
Surface Windows.
I don't know how to find out.
Okay, it's alright.
No problem. So it means that, see here, Syed, you and me are in the same subnet, right? But as per rule, we should not have, see, my packet is reaching your network and your packet is reaching my network. But still, you remember, from one network to other networks, it shouldn't be some different network. Then only our packet will go. But your private network, my private network are same. But here, I cannot see your private network. That's the reason it is coming. And your private network cannot see my private network. So what are the subnets? IP address schema I'm using. I have no idea about your private network, because at some point our NAT service is enabled. Okay. This is about private and public address. We'll understand about subnetting. Okay. So here I will use 192.168.1.subnet /0. Okay, /20. This is my, or else my computer IP address is 1.10. Okay, /25 24-bit mask. Now how my computer will calculate what is the host which is related to my network, my class. Say for example, if you are sitting in a classroom, then the other student who is, you can recognize who is your classmate and who is your neighbor class. Correct? Hello?
Yeah, right.
Yeah.
Because we are humans, we have some intelligence. But computers, how they will remember the pieces which belongs to same subnet or which belongs to different subnet? How they will remember? So computers will remember based on the subnet mask. Okay. So 224 is nothing but we can represent in other way 255.255.0.0. Do you know this conversion?
Yeah, we do.
Yeah. What is the subnet mask of class 24? 225 dot 225 dot
25.
sorry 255. See here, this is my error.
10, yeah. This is default subnet mask.
Of yeah, this is default subnet mask, right? Then this is also default subnet mask. So 24 is nothing but, see, if we convert into the binaries, 255 is all ones, all ones, all ones. So 8 ones plus 8 ones, 16 ones, 16 ones plus 8 ones, 24 ones. So now we are representing this mask with a shortcut of /24. You understand, right? So let's start converting this binary to decimal to binary. What is the binary equivalent of 192? One 128 plus 64. How much? 192. $168 binary equivalent. Tell me, you tell me now. Hello? Hello? What
Hello?
is the binary equivalent of 168?
168, you said?
Yes.
1010100.
Hello?
Yeah.
Yeah, you're right.
Correct, right?
Yeah.
Binary equivalent of 1?
7 zeros, then 1.
Then 10. 10 is 8 plus 2, right? 32, 16, 8. Is this correct?
Hello?
410.
Yeah, it's right.
Yeah, 1010.
101. Now convert this into decimal. See, /24 is nothing but this one. So if we convert into binary, okay. Now say this is 0, I will represent in different color. In the subnet mask, wherever you find ones, then once, it is a must match condition. Must match. Okay, or wherever you find zeros, don't care conditions. Or otherwise, remember this ones are belongs to network bits and zeros are belongs to host bits. Okay, again write the output. So here, first we'll do the AND operation. What is AND operation? 0 0 is equal to 0 plus 0 is equal to 0. 1 plus 0 is equal to 0. Or like say any combination 0 1 1 0. Only 1 1 is equal to 1. Okay, otherwise it will be 0. So 1 1 is equal to 1. 1 1 1. 0 1 is equal to 0. 0 1 0. 0 1 0. 0 1 0. Is that correct?
Yeah.
Okay, wherever we have above ones, there only we will get ones.
1,
Remaining
0, 0, 0, 0, 0, all 0.
is that correct?
Yeah.
And I said
Yeah, yeah.
for host it will be a don't care condition. So anything okay. Now this computer will remember this value. Okay. Now just convert here. Just convert here again to decimal. 192, 168, 1 dot. Here it will be x. So anything the x will be like 0 to 255. You'll consider as its own network. Remaining, if anything is deviating, say, so this is the value, right? Okay. Now, if I try to ping this machine, if I try to ping 192, 168, 2.5. Now it will convert the binary and it will check the value. 2 dot is 1 is nothing but here the last bit, here everything is same, here 192 168, here 2.1, here it will come 1 and it is 0. So wherever we have ones and wherever we have ones and whatever the output we have got, we should match the exactly, otherwise it will consider as a different network. If it is matching with the same value, wherever we have this is a must match condition, right? Wherever we have a ones. So here the resultant at the end the whatever the destination PC's IP address, if the binary equivalent is not matching with the must match condition, whatever the fields in the must match condition is matching, it is not matching, then it is considered as a different network. If it is matching, then it will consider as a same network. So if I ping 192, 168, 1.100. So what is the binary equivalent? This is matching with this one, right? This is matching with the second one is matching with this one. But now, see, even 1 is also matching with the 001, right? All ones. So it is also matching. Then this is considered as the same network and it will directly ping this one. So, okay. If you want to speak to a classmate who is in the same classmate, okay, who is sitting in the same room, you will directly go, right? Okay? Hello?
Yeah.
If you want to talk to a classmate who is in the same class, who sits in the same class, you will directly go to him. Okay? But whereas if you want to speak to other student who is in a different classroom, then you will go to his classroom, right, and speak to him. So in the same way, the computer belongs to in the same network. It will directly speak to him. The computer will directly speak to the destination computer directly. Okay. Whereas if that is in a different network, then it will go and take the help of what? Say you are here and your classmate is here, you will directly speak. But if you want to speak to a student who is in different classroom, then you will go to your door and you will enter again into other classroom door and you will go to here. So these two are called gateways. Okay. So here, if you want to speak to another subnet, then you have to go to your router, your gateway. Is that clear? Or see, I need to put it in another way.
Yes, clear.
Everybody, I'm asking.
Yeah, it's fine.
Okay. See, here we'll start checking. Okay. And in any network, so in any network, the boundaries are defined by the subnet mask. In any network, the first IP address is reserved for broadcast IP address. So here, the possible values are 192.168, 1.02, 192.168, 1.255. This is a possible value. Now, the in between value is 1.1 and the last but one value is 1.254. So these are called valid IPs. So, and this IP address is reserved for broadcast IP address. Sorry, network ID. Sorry, my miss. Network ID. And this IP address is reserved for broadcast IP address. Broadcast ID. So what is a network ID and what is a broadcast ID? Hello. Hello. I think you know this thing.
Hello.
Right?
Yeah, network. Yeah, we do know. Yeah.
Yeah, please. Network ID.
Yeah,
Is-
first one is network ID and last one is reserved for the broadcast ID, and the rest of them are the valid IP addresses.
Valid IPs. Okay, valid host IP address.
Yeah.
So what is a network ID? Okay, then I will put a analogy. So there are a classrooms, okay, some X standard, Y standard, okay, some classrooms. While you are walking on this way, while you are walking outside from outside the way, so you will say that this is a 10th standard, this is a 11th standard, right? So you are addressing about that classroom, okay, then that is called a network ID. So you are telling about that, you are addressing about some network, then that is called network ID. Once you enter into the classroom, and if you address every student in the classroom, that is called a broadcast ID. So you are addressing everybody in that classroom. So here, addressing every PC in that network is called broadcast ID, and addressing about one network is called a network ID. Okay. Now, you understand the difference, right? Or I don't know, I need to put it in a different way.
No, it's okay.
Okay. So network ID tells about the network. Broadcast ID tells about the each host in the network, in that network. Okay. Now if I want to ping, see if I change the mask to custom, we can do, see other than defaults, we can also do the customization. So if I put hello, Mazid,
Hello?
Mazid, I think Mazid.
Market is missing.
Yeah. Just we'll wait for 2 minutes. I think maybe some interconnectivity issue. Hello. Hello.
Yeah, are you gonna finish submitting today?
Yeah. Yeah. Why?
No, just asking. Yeah.
See, I know things, many things you know already, but at least at some point, at one single point, maybe learn from my teachings. That's my intention. Okay.
Okay.
And if you already know, that will be like a revision, and you will remember for some more time. Like it will be like beating your memory. Okay, we'll see. We'll continue. So if I make,
you couldn't get back the connection.
Yeah, try to get it to go to meeting one more time, man. If not, then just,
Use your cell phone. Please.
Oh, with your internet. All right, then.
No, but use your cell phone. You can use the cell phone.
So you can actually use the phone.
no problem.
All right, cool. So we're gonna carry on, right? All right. Then.
Okay.
What you say?
No, we'll continue.
Yeah. He's having some internet connections problem.
Yeah. Okay. If I make this as a 254, if I make this as a 254 is nothing but if I will reduce one red field into one green field, right? So here it will become slash 23. Is that correct? Hello?
Correct.
Okay. So if I make this as a don't host bit here, then this will also change. The calculated value as also changes. This will be X and this will be dot. Okay. Now what are the possible values in this one? Here the possible values are, so I will represent this in a binary 168, and this is the value, right? So all zeros, and first value is all zeros, and it will like say it will this all zeros as represented as 0, and it will be like 1, and then 0 dot it will be like 2, up to 0 dot all ones, right? And see here, this is a don't care condition. Any value is may be expected. So other possible value is 1. 1.0 to 1.255. So here, if I convert all these possible values into binary decimal, this will be like this: 192.168 0.1, sorry, 0.02. The last value is 192.168 0 dot, sorry, 1.1.25. So we are aggregating two networks into one, 0 and 1. So here, in the first case we will get 256 IPs. In this case, we will get 512 IPs. So first case is nothing but /24. This is /23. So -2 will always get a valid host IPs. So one is reserved for network ID. Here, this is a network ID and this is a broadcast ID. In between, we have 1.0 is also considered as a 0.255 is also considered as a valid IP address. These are no more a network ID or broadcast ID. These are valid IP address. We can assign it for those. So this calculation was clear, right? This calculation.
Yeah.
Oh, I will use this network adapter. Okay, go to TCP/IP and properties. So here it is updated by automatically. If I set this on, say for example 192.168 1.10 1.20, okay, if I click this, automatically default subnet mask was assigned. So why we require a default gateway? To go to the different subnet. So if it is not, the destination piece is not, destination host is not in the same network range or same class, sorry, same, I mean to say that same network, then it will use gateway. So I will use the gateway 192.168.1.5. If I click, it will accept. But if I make this 2.5, see, in order to go to different subnet, I require a gateway. But if gateway is in different subnet, what will happen? If the gateway is not on the same segment, that is defined by the IP address and subnet mask, you want to save the configuration. So what it is telling? See, in order to go to other classroom, you have to first exit from your classroom door, right? But you don't know your classroom door and you know your other classroom door. Is it possible to go out? No. So you have to be in the same subnet. Okay. If I say 0, it will also not saying that 0 is not belongs to same subnet. Okay, now I will change to 1. If I assign first IP address, network ID, if I assign a network ID, the combination of IP address and subnet mask is invalid. So it is telling that this is a network ID, why we are not allowed to use for a host. But use a broadcast IP address. It will also giving the same error. Okay. But if I use anything between 1 to 254, it will accept. Okay. Let's see if we change to slash 23-bit mask. 254, right? Now, in the previous case, if I put 0, it is not accepted. The gateway is not accepted. But here it is accepting. And in the previous case, if I put 0.1.0, it is not accepted. Here, it is not accept. It is accepting because now that is a valid host IP address with this mask. Okay, and if I put 0.255, it will accept. Okay, this is how the IP addressing will work. So you understand this one, right? Subnet mask, how it will work. Okay, then I will give some shortcuts. So if you consider slash 24 as a base, what is slash 24? How many IPs will get in a slash 24 network? 0 to 255. How many? 0 to 255. Total how many?
254.
256 IPs. Minus 2 are valid IPs. Like say for example, 254 valid IPs. But total IPs are 256. If I aggregate slash 23, then double to this one, 512 IPs. Minus 2. Okay. If I divide network, see slash 25 is nothing but again we are dividing the slash 24 network into 2. So 128 IPs minus 2 are valid ones. If we go on like this, 64 IPs minus 2. Slash 22, 1024 minus 2, slash 21, minus 2. These are the valid number of IP address and valid number of IP addresses in each subnet mask. Okay, so just remember this table and try to give try to find the valid network ID and broadcast. So I will give some assignment. Is that okay? Hello? Hello, everybody is there?
Yeah, we can hear you.
So can I give the assignment? The practice?
Sure, sure.
Okay. So for this network, just calculate what is the network ID and broadcast ID. This is slash 22. See, sorry. Here I should use some IP addresses. 22. Here 10. So these are the subnets. So I need a network ID and broadcast ID. And how many IP address in that network, and what is the valid IP address count in each and every network. Hello?
Do we have to do it now or for tomorrow? That's
For tomorrow, just
Oh.
Oh, I was thinking about now.
Okay.
just
Hello?
a moment. Yeah. Hello?
Yeah.
Okay. Now let's start the transport layer. So do you have any questions in network layer? You want to learn more things? But anyhow, assignment will help you to get more notes. If everything is goes well, then you understand everything. Any questions from some networking?
Yeah, are you recording the lectures?
Sorry?
Recording.
Yeah, I'm recording this today's session. Actually, that coordinator will recording the session every day. Okay, now the layer 4 is transport layer. What is it? What do you know anything about transport layer? Do you know anything? Anything is okay.
It's an end-to-end service between the upper layer and the lower layer. But
More answers.
It's a core layer of voice enable.
Sorry?
It's a core layer of voice enable.
Why it is 4 layer?
Because TCP/IP works on this layer.
I mean to say that TCP IP is not works on this layer. IP is again a network layer, right?
Yeah, IP is like TCP. Yeah.
Yeah, TCP IP is a combination of network layer. Without network layer and without data link layer, TCP IP is useless. Sorry, I mean to say that transport layer is no use. Okay. Transport layer. The two types of processing we will done in packet. One is TCP type of connections, another is UDP type of connection. What is a TCP IP of connection and what is a UDP type? What is a TCP?
TCP actually connection oriented and it's reliable, and UDP is not is connectionless. It is not reliable, and TCP requires acknowledgement, which doesn't require in case of UDP.
Okay. So TCP is a, I mean to say that it's involves in the acknowledgement, so it is called as a connection oriented. And UDP is a connectionless, so here no acknowledgement is happening. Okay, now
So TCP is port number 6, UDP is port number 17.
I should. TCP port numbers. Port numbers. See here, list of TCP and UDP ports. It is not just a single port. What you said, port number 6 and 17, right? Hello? So these are all port numbers. So not just one port number for TCP or not just one port for UDP. So for each and every service, the TCP are identified with the help of port numbers. Okay. So we have a range of like so these many ports. We have about 65,000 ports in the like for services. For each and every service, say radio service identified by 1813, and Cisco TECO, it's used for 197, 1975. HSRP used as 1985. Okay, so these every service, so each and every service is in like identified with either TCP or UDP. So HSRP is a UDP protocol, so it will not work on TCP. And so each and every service, either it will be in a TCP, depending on the service it is giving. So as you said, TCP is a connection oriented. UDP is a connectionless. Okay. Now we'll understand more about TCP. TCP not only involves in acknowledgement. First it involves in three-way handshake. What is a three-way handshake? Hello?
Hello.
What is a three-way handshake?
Three-way handshake is actually requires acknowledgement.
So before starting communication, it will involve in a three-way handshake, TCP. Source and destination. Sorry? So here, it will first source will send a sync message. Then destination will reply with a sync message. Destination will reply with a sync plus acknowledgement message. Then source will reply with a acknowledge. So it is telling that, okay, I want to start a communication with you. Okay, it is replying with the SYNAC. Then okay, I'm ready sending the data. Source will replying with the acknowledgement. So this is called three-way handshake. Okay. So TCP is not only for reliability. See here, it is responsible for error recovery. TCP is responsible for error recovery. How the errors are recovered in the TCP. So, say for example, if it is this source is sending some packets to the destination PC, say source sends 100 bytes of information. So it will give the sequence number of 100. Then destination will acknowledge 101. Now it is telling that okay, I received 100 bytes, so just send from 101. Okay, then he is sending the next 200 bytes, sequence number 200. Then he will reply with acknowledgement 101, 201. So he again sends a packet like 300. Next source is sending next 300 bytes, sequence number 300. Now he is again replying, or he is not getting a reply of 301, and still the last acknowledgement is 201. Then the source will understand that 301 packets are missed by the destination. So again it will resend the packets. Okay, sequence number 300. So this is how source will identify which packets are missed by the destination. So this is helps us to recover the errors. So this method is called forward acknowledgement. Okay. Hello. Any questions?
No questions.
No question. Okay. Then see the forward acknowledgement. See, for each and every packet it gets acknowledgement. So here sending and receiving the acknowledgement again, next sending the next packet. So it involves in a latency, right? It will involves in a delay, right? See, if I say everything like for each and everything, like just like me, if I acknowledge you and again I am moving forward, right? So I am getting the acknowledgement whether you understand or not. So if I acknowledge for each and everything, then that will be like very slow, right, compared to?
Yes.
Yeah. Yeah, Mazid. Hello.
Yeah, guys, sorry, I have a problem with my connection in the area. I called Comcast, so now I'm okay.
Okay. So now we are discussing about transport layer. We have completed the IP addressing. So I've just started the transport layer. Just for Mazid, just I am rewinding once again whatever we have discussed in the transport layer. Transport layer is like a layer 4 which involves in as I said, it involves in a sequence number, service number, and it also involves in the reliability, right? So we send the data in two types. One is in TCP and another form is UDP. So TCP is a connection oriented. What is a connection oriented, Mazid?
What's say it again, I'm sorry?
Sorry, TCP and UDP, transport control system. So transport layer is responsible to send the data in either in a TCP or in a UDP. So TCP is a connection oriented. What is a connection oriented? And another one is UDP is a connectionless. Connection oriented is it involves in the acknowledgement. Say sending one packet and getting the acknowledgement of that packet. So okay, I have sent the packet. Then destination will reply back with the acknowledgement saying that I have received the packet. Whereas this is called a connection oriented. Like it is ensuring the packet is delivered correctly or not. Whereas UDP is a connectionless. It will involve. It doesn't involve in the any acknowledgement. It will just send the message to the destination. So it is least bothered whether the packet is received or not. Okay. So we are now discussing about the TCP again in detail. So okay, before starting any communication, source will check with the destination saying that I'm sending the data. I'm ready. I'm ready in sending the data. Okay, then I am also ready to receive the data. So this is called SYN message, and the reply back message is called SYNACK message. And then source will reply back with the acknowledgement. Fine. Then they will start the actual process. This method is called three-way handshake. Okay. Yeah. Are you able to see my screen, Mazid? Hello, Mazid. This is for you. They already listened this one. Hello.
Yeah, I'm listening, yeah.
Are you able to see my screen?
Yes.
Okay.
Yes.
Then TCP is also responsible for error recovers. Okay. Say for example, source is sending 100 bytes of information. Sequence number it will put 100, and the destination will acknowledge with a 101. Acknowledgement 101. And then source will send from 101 to 200, next 100 bytes. Sequence number 200. Then destination will reply with acknowledgement 201. Then again source will send with the sequence number of 300. Again, if the destination is reply back with acknowledgement 201, then 201, then it assumes that source will assume that this packet is missed by the destination. So again it will resend that packet, same packet. See, sequence number 300. So this is how the source will understand which packet is received by the destination and which was missed by the destination. So again the source will resend the missed packets with the help of acknowledgement. This method is called forward acknowledgement. Here for each and every packet, here we are acknowledging. So here it involves the second packet is, even if it is ready to send, but still it will wait for the acknowledgement for some time. So this involves in the latency. So delay. Latency is nothing but delay. So here the delay is more. So to overcome this situation, TCP again come up with another method called delayed acknowledgement, where source and destination will send certain packets. Sequence number 100, sequence number 200, sequence number 300. Source will send a bulk of packets like 300 bytes at a time, and now he will expect one acknowledgement, acknowledgement 301. Then he will send next 3. So here also if anything miss by acknowledgement number, it will understand which packet is missed and it will send back again. So this is called a delayed acknowledgement. Here delay is nothing but like we are replying with the destination is replying with certain number of packets or certain interval of time. At certain interval of time, it depends number of packets or number of time interval. Okay, it is not necessary to be a time or it not necessary to be a packets, but it depending on the negotiation they will come up with one time. Okay, so this is called a delayed acknowledgement. And TCP is also not only responsible for flow error recovery, it also responsible for flow control. What is a flow control? Hello, any guesses from anybody? You understand error recovery? Everybody. Islam, Syed, Mazid.
Yes.
Yeah.
Okay.
Yeah.
So here the flow control is like, say for example, okay, now I'm giving the lecture, right? But if I don't know your capability, see, I cannot, see if you are, like if you don't know anything, I need to come from the scratch. I need to explain each and everything detail. If you know something, then I will speed up the things, right? From my side, from lecture side. So here, I need to understand what is the capability of yours. The same way, source and destination. See, we have a slow bandwidth here in between. I have to send in a slow. Okay, if I have a high bandwidth in between the infrastructure, the cable and everything between the source and destination, if I have a big bandwidth, I need to speed up the things, right? Hello? If I send in a constant speed, which is not matching with the slow speed and which is not matching with the fast speed, then I will always deliver the packet in a constant time. So we don't know exact bandwidth. If you don't know the exact bandwidth in between, we will always, we will deliver always with a constant speed. So we will not use the effective bandwidth. We will not understand if you not understand the bandwidth, then that will be a problem. So if you have a more bandwidth and if you are still sending in a smaller amount of data, that is a waste. And if you have a less bandwidth and if you want to send a bulk of data, then that is also useless. So to understand the bandwidth, now TCP have a flow control mechanism that is called. So first I will explain the method and I will explain here. Source and destination. Now it will send 1 byte of information. Okay, first sequence number 100. Then he is reply back with the acknowledgement 101. Then source will send 2 packets this time. Sequence number 200, sequence number 300. Destination reply back with the acknowledgement 301. Now he will reply back with 4 packets. Here first time he sent 1 packet, second time he sent 2 packets, now he sent 4 packets. Now he receives a successful acknowledgement, he will increase to 8 times. Okay, see, he like source is gradually increasing, exponentially, not gradually, exponentially is increasing the rate of data every time. So if, say for example, in this case, this is 400, sequence number 400, 500, 600, 700. Now if this is sent with the acknowledgement with 600, then he will tune to this 3 at a time. So you will understand what exactly the bandwidth we have from source to destination based on the acknowledgement number. And so here if we get a successful 701, then he will increase to 8. So likewise it will keep on increasing, and at some point source will understand the saturated bandwidth, exact bandwidth. So this is called slow start. So it will start with slow, but it will speed up the things very fast. So one example is that if you copy a file from one drive to another drive, first it will give, see, even though you know that this file size is very much low, but it will give 1 hour first. For couple of minutes, within couple of minutes it will give the exact time, correct 10 minutes. Say for example the time to take is copying this packet is 12 minutes, but first 2 minutes, 1 minute, 2 minutes, within 2 minutes, it will show as a 1 hour. Then after some times, it will give the exact value. In this case, slow start is working. So first it will send slowly. So where with that bandwidth, it will take 1 hour, but it will speed up the sending the data, and it will know exact what is the capacity, what is the bandwidth between one drive to other drive, and it will give after some time it will give the exact time. So have you noticed anybody? Hello? Hello?
Hello?
Yeah, have you noticed this this behavior? Usually, or when we are copying something, some file, big file, usually we'll see this, right? So this is called slow start. So this is how it will control the flow. TCP will control the flow. And TCP is not only responsible for error recovery and flow control, it is also responsible for congestion avoidance. Okay. What is a congestion avoidance? What is a congestion? Say for example, in our class, okay, getting acknowledgement is a three-way. Like say, even though you are intelligent to like take the lecture very fast, but at some point your brain will exhaust, right? You now at that point, even though your brain will not take any inputs, correct? Say if I take a one day session long, then your brain will start exhausting, right?
Yeah.
Your brain will not take. So here, whatever I deliver, that will not go into the brain, and it will be destroyed. Your packet will be not reach you correctly. It will go it will reach you, but it will not process properly. So that will leads to the congestions. So in the same way, from one source to other source, you send a data like 4 MB data. So here we have a buffer of 5 MB. In this computer, in this router, we have only 5 MB buffer. So once the 4 MB is completed, now next 4 MB will send. So here only 1 MB packet is taken. Now it will go, the 5 MB data is stored in the buffer, and no buffer is free. Now the remaining bytes will be get lost. So here, in order to understand, see, and if he doesn't know what is the buffer capacity of destination, and if he keep on sending, that data is waste. It will go into vain, right? There is no use of that data, and this is keep on sending the data. So this is creating some issue. This will create some issues. So the buffer, to overcome this buffer issue, we have a congestion avoidance method. Say for example, this is source and this is destination. Okay, now we'll understand there are only 300 bytes of information is there. Okay, only the buffer size is 300 MB. Now it will send a sequence number 100, sequence number 200, sequence number 300. Now the buffer is full. Now the destination will reply back, acknowledgement 301, my window size is 0. So this is called a windowing. Okay, windowing. Now the window size is also tells what is the free amount of buffer left with now. So now the source understands that, okay, it receives 301, but it is telling window size is 0. So he has no buffer at this moment free. Now I have to wait until its next acknowledgement. So next acknowledgement, once he processed the buffer and he processed the data and this buffer is cleared, now he will tell acknowledgement 301 window size 300. So here this window size is now become as a 300. Now he will send the data next 300 bytes. So this window size is changing from 0 to 300. This is called a sliding window. So sliding window will help us to understand what exactly the network it is. Okay, network buffer size. So this will avoid the congestions. So TCP and TCP will help us in flow control, error recovery, and congestion avoidance. So these are the main things involved in the TCP. But whereas UDP, it doesn't involve in the acknowledgement, it doesn't know anything about acknowledgement, window size, everything. Okay, it will simply forward that one. Why we use TCP and why we require UDP? So TCP involves in latency, it's some delay for acknowledgement, everything, waiting for signals. Whereas UDP, it doesn't involve in a handshake. So it is very fast. So why we require a TCP and why we require a UDP? So see this, now your turn to tell the answers. Hello?
Hello, UDP is required for where we don't need any acknowledgement. Suppose unicasting.
Okay, see unicast is also involved in TCP, right? Unicast is not
But,
necessary.
No, not saying this. I forgot that terminology is.
So here mostly TCP is reliable and UDP is unreliable, right?
Yeah.
And TCP, if you have more bandwidth, like say for example, my question is, okay, so we have a TCP, we said that it involves in the latency, it involves in the, like say I have a good bandwidth from one computer to other computer, okay. In this case, I have very good infrastructure, very good bandwidth, very good buffer size, all the pieces are very high end, all the infrastructures are very high end. So can I use always TCP here, because we have very good bandwidth where it will not create any latency, it will not create any over congestions, okay. Can I use always TCP because it is more reliable? Can I?
No.
Why? So Islam.
Slow. It is slow as well.
See TCP. So now network is very high end, and very fast. Bandwidth is very high. Now the processing speed and buffer size, everything is increased in the PCs also. Bazir, Islam, please, you also participate in this one. You have to tell something.
Trying.
Yeah, I don't know.
So why we can see TCP is more reliable, right? And we have fast
Yes.
network. We have very fast network. In that case,
So what is the question again?
we have a very good network. So these two pieces are communicating. So here I said TCP is more reliable, okay, compared to UDP.
Yes.
So now my question is that, can I use always TCP between these two pieces? Like for others I will use UDP or TCP, but for this case, these two pieces are in the same network and they have their own like very good infrastructure. This is a 10 gig link and this is very 10 gig, and we have a very good amount of buffer. We have a very good processor. Everything is very high end, where even TCP, if you use TCP, it will not create any latency. It will not create any delay. So in that case, can I use TCP? Because it's more reliable. Can I use? You got my question, right?
Yes.
Mazid?
Yeah, I get it, but I'm thinking now.
So tell me. Don't Google it. Okay. Can I? Now?
Hello.
Yeah. So use your common sense. Then only you will understand.
But isn't
Hello? Hello?
hello?
Yeah, tell me.
Yeah, what I was saying is, isn't TCP is itself is slower than UDP? So
But
it's
see
better
here,
to, I mean, I understand
here,
you're saying that
yeah.
you're giving faster than it and everything.
Yeah. Yeah. Here the answer is no. We cannot never replace the UDP with a TCP. Why? Because even though we have a very good network and everything, some examples, UDP example, the ports which are using SIP will be in UDP. So SIP is nothing but a voice. Okay. If I use a TCP in voice, okay, while we are talking in between, if any packet misses, sometimes we are not audible to each other, right? That packets are missed by your computer. If it is used in a TCP, your computer will request the same packets again to my computer. Again, my computer will resend that packets again. Now we are in a conversation. Now we are receiving some older packets. Say for example, I said hello in the beginning. That packet was missed. Now we are in a conversation, and if hello gets to your computer and you listen that hello, hey, why Ramesh is again telling hello now, right? You understand, right? What I'm trying to say?
Yeah.
Hello, every. So here, voice cannot be in a TCP. So TCP weird. So in a real-time protocols, voice streaming, if they use in a TCP, you will not get a synchronized communication. So you will not listen exactly what they are saying. So here the order may change. That will create a big problem. So here we always used to, no matter whether the network is fast or network is slow. So some protocols never replace with the TCP or UDP protocols with the TCP protocols with the UDP. So while you are watching any video streaming on YouTube, again if you are going forward and again if any packet missing, then if again it comes back and playing again, coming back, going forward, coming back, then that will be a not effective video, right? So here UDP, no matter whether if you miss anything, whatever comes, that will play. So we cannot replace UDP with the TCP. So UDP is for some special purpose, has its own purpose. Clear? Any questions? Everybody should reply.
It's not that clear with me, but I have to because I missed some parts, so I have to watch the lecture again.
Okay. Just ping me your mail ID so that I can forward it to the your mail ID.
Yeah, please do that.
Okay. Or else, say, for example, I will contact this consultant training consultant people. They will provide you with video. Okay.
All
I
right,
will.
thank you.
So you haven't missed anything in the TCP transport layer. I have repeated almost everything. Just we have started at that moment and I repeated everything. Okay. So this is about TC transport layer. Now we will start the technology from tomorrow onwards. Same time. Okay. So we'll start with some basics of networking devices, and then we'll move to the switching part and then routing part.
All right.
Okay.
All right. See you tomorrow then.
So any questions? Any questions from today?
No questions.
No question.
No questions, right? Okay.
What's the subject gonna be tomorrow?
Tomorrow we'll understand something about some components of routers and basic management
Switches.
of routers. Yeah,
Yeah,
switches or
switches.
routers, any networking devices. Basic networking devices, how they will have basic management.
All right. See you tomorrow.
See you tomorrow. Bye.
Okay, thank you. Bye.
Bye. Good night.